Chapter 22, Test Walkthrough. Question 1. A and B are similar containers. Remember, that means that one of them is an enlargement of the other one. Okay, write the ratio of volume container B to container A. It doesn't tell you to simplify it, you just have to write the ratio of the volume. So container B has volume 64 and A 27. That's all you have to do. Okay. Now that is volume. So if I had area and length, that would be slightly different. If you notice, 64 is 4 cubed and 27 is 3 cubed. And because when you do volume, you've got cube units, whereas with linear scale factor you haven't, this should just be the cube root. So the linear scale factor would be 3 to 4. Sorry, the linear ratio would be no, it wouldn't. It would be 4 to 3. 4 to 3. And the area would be 4 squared to 3 squared. 16 to 9. Okay, for the next one, the surface area, we're going to be looking at the area one. So I've got 16 to 9. This is shape B, this is shape A. And shape A has 6. So if it was easy to multiply 9 to get to 16, you could do it that way. To be honest, I'd probably go from 9 to 6 this way. It's a little bit easier. If I did it without a calculator, this could easily be a non-calculator paper. I could divide 9 by 3 to get 3, and then times by 2. Alternatively, you could just times the whole thing by 2/3. And here, you could times this by 2/3, because 6 is 2/3 of 9. Okay, well 16 times 2/3 is 32 over 3. So we've got 10 and 2/3, which is 10.6 recurring, or 10.7 metres squared. Question 2. A new hybrid costs £26,000. Each year the car depreciates in value by 15%. That's unfortunate. Work out the value of the car at the end of 3 years. So we start off with £26,000. Now depreciates means it's going down by 15% each year. So if we started at 100%, went down by 15%, would have 85%, which is a decimal, 0.85, and it's 3 years, so it's to the power of 3. And that is £15,967.25p. Okay, question 3. A student tweets a message. Number of people reading the tweet trebles every minute. Remember, trebles times 3. After 2 minutes, 18 people have read the text. The tweet, sorry, keep thinking it's text. Tweet. Calculate the number of people who've read the tweet after 5 minutes. Well, it trebles, so I could do 18 times 3 for 3 minutes, another 3 for 4 minutes, another 3 for 5 minutes, or I could just see that 5 minutes is 3 minutes after the original 2 minutes. Either way, I'm doing 18 times 27. So 486 people have read the tweet after 5 minutes. Not bad. This next part's a bit trickier. It's for the higher plus students. Okay, now if you use this, it can help you figure it out a little bit. So you've got 18 times 3 trebling a number of times, but it's not the number of t minutes, because we start, 18 is our 2 minute number. So it'd be t take away 2. That's one way of writing it. Now actually, I can improve that further because I can go backwards from this 2 minutes to 1 minute and 0 minutes. Thinking that it's trebling every 1 minute, well, after 1 minute, if you do the inverse of trebling and divide by 3, 6 people would have read it. And at 0 minutes, 2 people will have read it. So this is actually 2 times 3 to the t. They also allowed the in-between one with the 6 minutes, so you could have 6 times 3 to the t minus 1. This is nice because it shows the original value. Question 4. The force required to stop an object is proportional to the square of the speed. So F is proportional to s squared. In other words, F is some value multiplied by s squared. Can I say that is not the formula? A couple of you just left it like that. You have to find the value of k to say that that is the formula. Okay? So, if the force required is 3,000 newtons, that's something multiplied by s squared. S is 20, so it's something multiplied by 400. We're still in the calculator section, yeah? So you can just do 3,000 divided by 400. Some of you decided it was 300 instead of 3,000. Please don't change the numbers. You will end up getting it wrong. Okay, so you'll have k equals 7.5. So the formula is F equals 7.5 s squared. Okay, you're now given this force. So you've got 1920 equals 7.5 s squared. Divide both sides by 7.5. S squared is 256. So divide by 7.5. Divide by 7.5. And then square root. The speed is 16 meters per second. Question 5. Unit conversion. First of all, centimetres squared to millimetres squared. Well, centimetres to millimetres times 10. So centimetres squared to millimetres squared is times 10 squared. 6 times 10 squared, 600. Okay, centimetres squared to metres squared. Well, centimetres to metres is times by 100. No. Some of you might have made that mistake. Divide by 100 because you expect the metres number to be smaller. So centimetres squared to metres squared, divide by 100 squared. Divide by 10,000. 25,000 divided by 10,000, 2.5 meters squared. Question 6. A gas boiler uses 20 meters cubed of gas in 1 hour. 1 hour, 20 meters cubed. So how many to reach 30 meters cubed? Well, hopefully you see that the number 10 goes into both of those. It's a ratio here. So 30 minutes, half an hour, is 10 meters cubed, and 3 lots of 30 minutes, which is an hour and a half. (30 meters cubed). Okay, how much gas would the boiler use in 3 hours and 15 minutes? Well, 3 hours would be 3 lots of this. And 15 minutes would be half of 30 minutes, which is 5 meters cubed. So in total, 65 meters cubed. Question 7. The cost of petrol is directly proportional to the number of litres. So the cost is K times the number of litres. Once again, we need to find the value of K. So £10 is K times 8. Divide both sides by 8. 10 divided by 8 is 1.25. You could do that by halving it again, and halving it again. If you look at it like this, 10 divided by 8 is 5 divided by 4 is 2.5 divided by 2, which is 1.25. So C equals 1.25 L. Work out the cost of 50 litres of petrol. So the cost is 1.25 times 50. Some of you got that one a bit wrong. You could just times it by 100 and then half it, because 50 is half of 100. So this is the same as 125 divided by 2, 62.5. But it's money, because 50 is half of 100. You can times by 100 and then half it. This one was surprisingly easy. I don't think they'd realised this. Lots of you did this one correctly. Francis has £50, but you already know that 8 litres costs £10. So 8 litres are £10 for £50. That's times by 5, times by 5, 40 litres. Question 8. You've got 2 cones. Now the really key thing here is these are mathematically similar. Okay, so let's put numbers we know that's 12, 21, 36. So what's the scale factor here? Times by 3. What number do I times by 3 to get 21? 7. That's why that's 7. Okay, now that's length. The ratio of the surface area of the smaller cone to the larger cone. For lengths, the ratio is whatever the smaller cone is, the larger cone is 3 times as big. So for area, instead of timesing by 3, we're going to times by 3 squared. So it's 1 to 9. Let's just check we got it the right way around. Smaller to larger. 1 to 9. Question 9. Some different graphs. So when it's directly proportional, that's just a linear graph. Direct proportion is our standard linear graph. So that's D. Proportionals, this is directly proportional to the square. Well, x squared looks like b. So I've just got 2 left now. Y is inversely proportional to x and inversely proportional to the square of x. Well, you might notice that this one only has positive values for y. Only has positive because it's about square. And this is our classic inverse proportional 1 over x. Question 10. A ball is thrown vertically upwards with a velocity of 20 meters per second. Its height in meters t seconds later is given by this, which is then drawn. Okay, so that is this graph here. That's this graph. Use a chord to estimate velocity 3 seconds after being thrown. Now, strangely, it's actually asking you the method which you need to use. And it says a chord, not a tangent. A tangent would be for this, where it touches once. That's a really bad tangent. Touches once. Whereas a chord is between 2 points. Okay? So if we look at velocity 3 seconds after being thrown, lots of you just read off that point. It's not actually what it's asking you. It's asking you to draw a chord, okay, a straight line with the same velocity at that point. And then we'll find the gradient. Okay, so we'll find the gradient in a minute. Let's get my ruler out. So for chord, it's got to be between 2 points. Okay, I'm going to take 2 points that are near the point I'm involved with that are on clear corners, so I'll be able to find the coordinates of them really easily. Okay, put my ruler between these 2 points. And then draw my line. Okay, now I need to find the gradient here. Now be really careful, because some of you thought that the scale was the same on both, and then for that case would have said 4/2. It's not correct. So the scale on my y-axis is one little box that's worth 1, so that is 4. But the scale on my x-axis is not true, it's not the same. If I look at each of these, they've got to be 0.2 each. So this is 0.4. So change in y is 4 divided by 0.4. Let's multiply them both by 10. 40 divided by 4, which is 10. However, my gradient is not 10 because it's clearly going down and not up. This is actually negative 4 change here. So my gradient should be negative 10. So my velocity is negative 10 meters per second. Interpret it. What that means is after 3 seconds, the ball is falling 10 meters per second. So at 3 seconds, the ball is falling at a rate of 10 meters per second. All right.